That last slide, make sure you got the answer that I got on the function problems. And today we're going to start talking about function in a little bit different terms. So if you look up the definition of function, it's a relation between a set of inputs and a set of permissible outputs with the property that each input is related to exactly one output. That is a confusing definition, but it's not actually that complicated. The important part here is the last little blurb of this sentence. And it's basically each input only gets one output, right? And I want to talk about that with kind of a silly example here that deals with Edgar Allan Poe, okay? And also a couple other of his buddies, okay? So Abraham Lincoln, Edgar Allan Poe, and Charles Darwin were all born in the year 1809. Okay, and we're going to talk about them in just a second. Before we do, I would like you guys to add in a couple vocab words in your boat books. Function. It's any equation where each input has exactly one output. Okay, we're going to talk about what that means in just a second, but for now, I need those word for word in there. And then this is also using a couple words that we haven't talked about a ton, input and output. I mean, the definition is basically in the word. An input is the number put in. What is going to be our X value? I mean, by process of elimination, you guys can probably figure out the definition for output. It's the number that is going to be our Y value. Okay, so pause the video, get those definitions in your boat book, and then continue when you're ready. So once we have those definitions, I want to come back to this super stupid example with these three gentlemen who were born in the year 1809. And I want to talk about basically just how a function machine works. Okay, so instead of using an equation, I want to use birth year as our function machine, right? So if I plug in Charles Darwin into my birth year machine, the number that I get out is 1809, right? So that works. And if I plug in Abraham Lincoln, right, I can plug him into the function machine and I can get out 1809. I got the same answer out, right? But it makes sense, right? They were both born in that year. What a function tells us is if we plug in one value, so let's say Edgar Allan Poe, I can't get out two values, okay? And in this stupid birth year example, that makes sense, right? Edgar Allan Poe could not have been born in 1809 and 1987, okay? It just doesn't work that way. Basically, our functions are going to work the same way, where each input only gets one output, okay? And it works on graphs too, okay? Remember, our inputs are our X values. So if I plug in a number over here, okay, and I look at the number that I get out, oh, hey, when I plug in -2, I get 4 as my output. And when I plug in +2, I get 4 as my input, as my output as well. And that's okay, right? Each input, 2 gives us -4, -2 gives us 4, right? They're the same output, but each input only got one output. Okay, again, we're going to run into trouble when we have a graph like this, okay? So here, if I plug in 2, what's my output? Is it 1.5? Is it -1.5, right? Like that input is giving us 2 outputs, and that's a problem for us. That means that this is not a function, okay? Because there are places on the graph where I can plug in an input, so for example, 2, and I get out more than one answer, okay? And the way that we can easily check to see if something is a function or not is with this thing called the vertical line test. A function must pass the vertical line test, and basically that means and sorry, I'll slow down here. I would like this in your boat books as well, and maybe give a little sketch on this next graph here. Okay, so if we look at the black line here, we would say that this is a function because no matter where I draw a vertical line, right? It's called the vertical line test for a reason. It's a straight up and down line. No matter where on this graph I draw a vertical line, it's only going to hit the graph once. It hit it once there, it hit it once there, it hit it once there, it hit it once there. Anywhere on the graph I drew a straight up and down line, it's only going to hit my graph one time, okay? So if I look at a couple of these side by side, pretty normal shapes for graphing, right? On this side, no matter where I draw a straight up and down line, oh, boom, it hit one time. If I do it here, boom, one time, right? If I did it way over here, it would hit all the way up here, but it's only going to hit the graph one time. So this is a function, okay? It passes the vertical line test, and that tells us that each input only has one output, okay? Over here, though, if I draw a line, I mean, lots of places, if I draw a line over here, it doesn't hit at all, but that's actually not a problem for us. What is a problem is if I draw a line straight up and down and I hit one, two times, we would say that this is not a function because it fails the vertical line test, and some of the inputs give you more than one output. That means that it can't be a function, okay? And this seems like semantics. It's like kind of a dumb little definition, but it does kind of come up. And if we think back to the birthday problem, there are some places where this has some utility for us. Okay, so I would like you guys to go ahead and open up a new tab, and I want you just to go to Desmos, just desmos.com, not student.desmos.com, just desmos.com. It's just a graphing calculator, and I would like you to graph one of these four for a pick'em here, and I want you to decide, is x squared plus 11 a function? Is x equals y squared a function? Is y equals absolute value? Okay, that's the straight up and down lines, or this one, right? We've got x squared plus y squared equals 9. Some of these are functions, some of them are not. I would like you to go to desmos.com. If you want some help typing them in, this is kind of like the keystrokes that you're going to need to make it look like what I had on the last slide. I would like you to enter one of these, and I want you to figure out, yo, is it a function or not? And I'll be right back on the next video.